Welcome, everyone. Welcome to this introduction to API security session. Hopefully, that's the one you're here for. If that's not the one you're here for, stick around anyway. You'll likely learn some stuff. My name is Ali Mitchopol. I'm a developer advocate at Postman. And what I do, I get people that are more knowledgeable than me on different topics and get them to speak to you. So I'm here with Ronak and Manoj, and I'm going to give them a chance to introduce themselves as well. Ronak, do you want to go?
Hey everyone, I'm Rana Kotaria. I'm a senior security engineer at Postman. I am part of two teams currently. One application security, where I work with Manoj, and the other team is the product trust, which is a new team at Postman, where we make sure that platform is a trusted platform and what we have enough security and governance feature for you guys to be for you guys to make sure that you are secure while on our platform.
Cool. Manoj, do you want to go ahead?
Hey everybody, my name is Manoj Vignesh, a senior security engineer at Postman. So my primary responsibility is cloud security engineering, and my responsibilities also involve application security.
Cool. All right. So as I mentioned, I'm going to be talking a bit at the beginning, but then I'll give it to them to actually talk about the important stuff. So a few things we're going to see today, mostly get everyone on the same page. What does API security mean? We might all not be expert on that, so we want to make sure that everyone starts from the same level. We then look at what is secure API design. You might be familiar with API development, etc., but security starts earlier than that. We'll have a look at the most common API vulnerabilities. How can you automate this type of stuff? Ideally, you don't want to be like clicking on buttons to test things every day. As much as you can automate things, the more the better. And then, as I mentioned, there's going to be a Q&A at the end, and we'll share some resources that you can use to learn more. So let's first get started with learning a little bit about you. I have two questions for you, and they're going to pop on the screen now. So please do answer. Two questions. The very one should be very straightforward. How much experience do you have with Postman? Can be no too little experience. You might be using a bit of Postman, but not like in an advanced way. And then maybe you know so much about Postman that you could write a book about it. I don't know. But yeah, that's the first one. The second one is a multiple choice question, which is when you develop an API, what are your top priorities? What's in your mind? Do you care about it being reliable? So like kind of uptime, it always works. Do you care about the security? Hopefully, if you're here, it means you care about that. Agility, reducing costs, quality, or speed of development. Maybe you're just thinking of, oh, I need that to get released by tomorrow. Let's get this out of the door as fast as possible. Okay, I'm gonna give it another 10 seconds for everyone to reply. And I think, yeah, we already like, answers keep coming. Okay, maybe another 30 seconds then. But hopefully there shouldn't be any big surprise. Okay, I'll stop the poll now and share the results so you can all see at the same time as me. So mostly we have like Postman users. You use it frequently. Might be just for sending API requests, just seeing what's coming back. Might not be using advanced feature. We have 4 people that could write a book. Please send us the links to these books. We'd love to read them. And then we have a few newbies, which is all good because we put you all on the same level anyway. And then in terms of the top priorities, reliability, security, and quality come first. Then speed of development, agility, and reducing cost. So we actually asked that question during our state of the API survey that we do every year, and you see pretty much the same thing came back. There was a few more people answering these questions. I think we had 18,000 people, I think, taking that survey. But yeah, quality comes at the very top. Agility, reliability, and security actually comes fourth. And that's one of the topics that we're going to approach today. So with that said, what you're going to learn today, you'll ideally at the end of the session, you'll be able to identify the most common vulnerabilities and mitigate them. Obviously, like seeing them is good. Being able to fix them is better. You'll be able to use Postman to monitor it and to automate some stuff. Prevent them by taking care of security from the start. So looking at security in API design, and then just talk about security best practices. But with all that, I'm going to leave you with Ronak because he can talk more about it than me, and he's going to tell you all about what does API security mean.
Yeah, thank you, Alamin. So let's answer this question, right? What does API security mean? We all know that, I'm assuming we all know that APIs are everywhere. The platform on which you're viewing this webinar right now uses APIs. The social platform where you heard about this webinar also uses APIs. Everything we do in the digital age, let it be shopping on Amazon, checking your bank account balance, or sending money to a friend. Guess what? All of these things, or the services that we use, uses APIs. So we are not surprised when Akamai's State of Internet report stated that more than 80% of the internet traffic is from APIs, right? Now, with this much traffic from API, the concerning part is that to support all those features that I just spoke about, to use the use cases of the modern web and mobile applications, APIs now need to carry more sensitive data, which is goldmine for hackers nowadays. So, in the report, State of API Security, they gave a really nice example. Before, the bad guy used to rob banks because that's where the money was, right? But today, the bad guys would hack APIs because that's where the money is now, right? So, hence, the API security has become the top priority for today's organizations. And so, when we ask someone, what does API security mean? To me, personally, it means that securing our most precious data. And that's what this question means, right? Uh, Cool. So now that we know what we need to protect and what API does and what we need to protect, let's talk about the security assessment that goes around. Security testing goes around the API realm. So in most cases, API security assessment happens on the far right end of the development lifecycle when we are ready to ship our application to production. In some organizations, we have also seen that they only rely on parameter-based web and API gateway for API security testing, which is not sufficient at all. Organizations need to have a full lifecycle approach to API security, shifting as left as possible. So what do I mean by shifting left? We need to shift left, meaning that we need to involve security earlier in the phases when we are designing the APIs, right? So Postman can help here. Aligning with Postman's vision for API First World, our API design platform has security baked right into it to make sure that we have keep security in mind from the start, right? So let's check that out. So I think this link will be pasted where we will paste it in the chat.
Yeah.
So
that's where you all get a chance to follow along. So we are going to paste that link, and Ronak is going to show you what you will be doing with it.
Yep. So let me open this link. Okay. So I hope everyone can see my Chrome browser. So what I'm going to do, I'm going to copy this link. And I already have my Postman app open on the browser, right? So once you have copied the link, just click on the import button.
So navigate to a workspace first, quickly.
Oh, right. Sorry. Yeah. Navigate to your workspace, any workspace that you want to import this API. Just while inside your workspace, go to import, go to link, and paste the link that you copied. When you hit continue, you should see something like this. So if you guys remember, or if you guys were part of the talk that we did with Joyce, Manoj, and I, we talked about the good bank APIs. In this session, we'll take that a little bit forward. So here in that session, we talked about mainly about the OWASP API vulnerabilities and how to find them. In this talk, we'll see when we have the API schema, what we can do with that. So today I'm only going to focus on the API schema. So I don't need to generate the collection for now. So the good bank API, this has the format of OpenAPI 3.0. I'm importing it as an API. And voila, I'm here. So this is the API. Go to the definition tab of this in the Postman app. So you should see the API schema in this text editor. You can see all the information about the API, what all the path for the all the path of the APIs, the security key components, etc., etc. Right. I hope we have everyone is following along so far. So
yeah, if you miss something, you have to navigate to the API tabs on the left, and then you'd be able to find what was imported. I think, Ronak, you are already there, so maybe
right.
Yeah, that's where it is. You can probably hide the sidebar, by the way, to get a bit more space. Yep.
Okay.
Nice.
Cool. So you can see that when you imported the schema, in the below section you can find issues find in the schema. So there aren't any errors, but I can see there's a warnings. So this is the feature I mentioned earlier about that Postman can help when shifting left, right? So this is a beta feature that we launched a few months back. These issues mean or warning means is these are not these are not errors in your API schema. These are the potential security issues that exist in your API. That's what this means. So let's look at let's look at one by one each of them, right? So the first one is it says that security field is not defined. Now, if you are familiar with an Open API spec, you would know that here it says there's a component, there's a field called security. And just like how we define Open API servers, tags, we need to define that. But I'm not quite sure what does it mean, right? So let me see in the Postman app, it will also show you that possible fixes for it. So when I click on this, let's see what it has to say about it. So it will redirect me to this particular section. Here I can see the warning that was shown to me. Security field is not defined. Severity is high. The issue description says that if the global security field is not defined, the API does not require any authentication by default. Anyone can access the API operation that do not have a security field defined. Got it. So what does that mean is the API endpoints that I have here, if I don't define a global security field, by default, they don't require any security scheme or authentication schemes. Okay. Now, because I have imported this API and this API already, I know about this already, the API endpoints. I can see that some of the API, like this / endpoint, which is just a ping endpoint, which is just to check whether the service is live or not, the APIs are live or not. This does not require any authentication schemes. So I would not want to enable this right now. Let's see, right? And let's see what all other issues are there. So the same thing you can see here, the fix for it, right? Security field should be defined in the security schema, in the schema. That's what we need to add if you want to fix this. But
you could define it at each level as well. Like if you had enough time, you could do it like for each endpoint that need it, right?
Okay. Yeah, that's what I'm coming to, right? So we can define it in each point as well. So because that particular API did not need any authentication, but my other API, like user put API, which updates user information, that needs authentication. So what I did is I have defined API key auth here in the security like this. So when this API is called, it will require an API key. And this is defined again under the security component, security schemes. So if you're familiar with OpenAPI spec, this is how you need to define. And then you can reuse this particular auth scheme to in your APIs. Now, for now, I'll not define a global field as I mentioned, because there are few APIs which does not require any authentication scheme. Moving on to the second second warning that I got, right? So it says global server URL uses HTTP protocol. Now let me see what is the issue and what is the possible fix for this. So severity is medium. The server supports unencrypted HTTP connection. All requests and response will be transmitted in the open. Anyone listening to the network traffic with while the calls are being made, can intercept them. Okay, this I understand, right? Uh, so because my API server URL is HTTP, now all the API transaction that happens, for example, account transaction or account summary or admin credit can be visible by someone who is intercepting my network. It could happen that I am accessing this website on a public Wi-Fi and someone can intercept that. So that's not good. So what is the fix for that? The fix for that is to use HTTPS protocol as it says here. So yeah, I can do that. So I need to make sure that in my schema, I have defined it as HTTPS. So this is just the schemas. This is the step where we are designing the API. In the later stage, when we are actually developing the API, we need to make sure that our API supports this certificates and actually build as per the HTTP, actually build and uses HTTPS protocol. So that was the issue that the security warning identified, and now it is fixed. As you can see, it doesn't show up here anymore. Okay, there are a couple more here as well. This one says operation does not enforce any security scheme. So if I click on that, it will again show me here that says health ping. And so here, I did not specifically define any security schemes like this. So that's why it's showing me that operation does not enforce any security scheme. But we don't want this here. So this is false positive in my particular case, right? Because this warnings does not know that my API endpoint is a health endpoint. It does not need it, so it will show me the error, but we can decide whether to accept it or not. Moving forward, now I can see that create user again here as well. When we are creating any user via API, we don't need to have any API key with us because the API keys are generated after the user is created. Moving forward with okay, so here it says user change password. So this is strange. This API should have authentication scheme applied to it, but it is not. Maybe because while developing, the developer may have thought that, okay, we are anyway requiring old password, which can act as an authentication, which can authenticate the user. But this is not a good practice. So this we would want to make sure that only the user itself can change their own password. If it was a forget password API call, then it would have been fine. But in this case, we need to have the security scheme defined. So what I'm going to do, I don't want to define it globally. So I'll just copy paste this here. And like this. Like this. So when I save this, the error should go away. Okay, but there's one left. Similarly for login and similarly for account C. Again, there's an account summary issue, which again does not have any authentication scheme. So here you can see that this is actually a vulnerability. If this API was built according to this specification, they would not, the account your summary API would not have any authentication. So any user who knows the user ID of that particular user can fetch the account summary for this. So I did not have to actually go ahead and manually test it. I found out about this issue while I was in the design phase itself, right? So think of it like this: that you already have open API spec for your APIs. You did not start from scratch. You can use your existing schema, put it in here, and just see what kind of security issues you can find, right? So this API again would we would want to have an authentication scheme for this. And yeah, I think that's all the issues that we can find, right? So The one that says here is the health endpoint, the create user endpoint, and the login endpoint. These are the three endpoints that currently does not have any security schemes and the global security field. So let me do one thing. Let me do it like this. If I'll define the security scheme globally, and what will I do? I'll just I'll use this, right? So if I create a global scheme, that means all of my endpoints by default will have the authentication scheme of an API key. Now, why would I want to do this? By all the API endpoints, like you see that there was this in particular endpoint did not have the authentication scheme enabled. So they missed it. If we have defined it globally like this, then it would make sure that all the endpoints have the API's auth scheme, and we don't have to whitelist, go and whitelist each one of them. This is a very simple example. That's why very few API endpoints are there. But if let's say if an organization have typically have hundreds of APIs, in that case, this will not work. This approach will not work. So it is recommended to that we specify the security uh, global field and mention the default auth scheme. And then if we don't want in any if we don't want an authentication scheme for a particular endpoint, we should just whitelist it or blacklist it. For example, in this particular endpoint, right? Uh, I don't want a security scheme here. So what I would do is I'll do I'll do it like this. I'll mention an empty array. So with this, it will not show me any error. And it will still show me this error because it still assumes that this endpoint needs an authentication by default. Uh, and that's why it will still show me this issue. But in the future, now if someone messes out an authentication scheme, I would find out we will be secure by default. Right. So I'll go ahead and add that for all the other. So for create user, I don't need it. And the last one is the login endpoint, which does not need this here. Now, I know that these three does not need the authentication. This is kind of following the security best practices. So we by default, all the APIs have an API key authentication scheme, and we have blacklisted the APIs which does not require an authentication scheme. So this is what we can do while we are still in the designing phase. There are lots of more security warnings that are available within Postman. You can find out all about them here in this Learning Center page. So you can see that if the global security field is not defined properly, reusable security schemes are not defined properly, or if there is an issue with the API scheme like OAuth, OpenID Connect, or OAuth, if you are using a deprecated version of OAuth, then it will alert you accordingly. So there are many such cases that we can find out from here. So yeah, we'll post this link in the chat. Have a look at this, and you can also see the get to this via clicking the possible fixes button here.
Cool.
So now we are done with the design phase. We have secured the API schema, and now I'll hand it over to Manoj, who will make sure that this API, when developed, does not have any security issues, or if they have, we would want to catch them before they go to production. So over to you, Manoj.
Yeah, thanks, Rona. Yeah. So far we've looked at how we'll be securing APIs during the design and implementation phase, right? So now what we'll be looking at is securing APIs in the testing phase. So before we switch to hands-on on how we do security testing in the testing phase of the SDLC cycle, first let's understand what are the common vulnerabilities that exist in cyberspace. So OWASP, which is one of the open security community, what they do is they survey the IT industry and they ask every organization that, hey, what are the top 10 vulnerabilities that your companies have faced or the security threats your company has faced? And what they do is they collate all these details and create a report in form of this OWASP API security top 10 or OWASP web security top 10, OWASP cloud security top 10. But for this session, we'll be specifically looking at OWASP API security top 10. So these are the top 10 vulnerabilities that was recognized in 2019. So let's get into, let's say, a couple of them. So the first one, it seems this is the most common vulnerability that was seen in 2019 along API security, which is broken object level authorization. So what is authorization? First, let's define authorization. So authorization is actually a security control that defines what permission does a user have on an object. So let me give you an example. That looks like a definition, but here's an example. So let's say a Postman collection, right? Postman collection is an object here. What can I do with Postman collection? I can add requests, I can remove requests, I can add variables, collection variables and remove them, change them. So those are some of the actions that I can do. So those can be in the form of permissions. So objects, permission, and users are people like us. Now, talking about broken object level authorization, what it means is, let's say the workspace admin gives read-only access to a user. Read-only access of a collection to a user. And if the user is able to add collection requests, so that's a security violation, right? And that is what exactly is broken object level authorization. Here, the user was actually able to add request, do a write operation in the collection, even though the security enforced was a read-only, right? So that is one of the most common vulnerability that was seen in 2019's OWASP survey. Now let's get into one of the not so common vulnerabilities, which is called insufficient logging and monitoring. So think of a commercial place, think of a public place, and think of the cameras that are there to ensure that no malicious activities happen, right? If there are enough cameras set up in strategic locations, that means we can identify malicious activities happening in that commercial area, right? So similarly, in IT, we need to ensure that we strategically log and monitor the systems that is serving our customers. So insufficient logging, what it says is, if you don't have enough cameras in a commercial place, if you don't have enough logging and monitoring set up, that means we'll not be able to identify some of the malicious activities. And why do we want to identify malicious activities? Because we want to prevent them from happening. So yeah, by the end of the day, security is all about customer trust, right? So if we allow some malicious activity happening and the company or the service is not doing anything about it, that means the customer is going to lose trust on our things. Now let's look at one of the interesting vulnerability, that is injection. Yeah. So injection, as the name signifies, is injecting some code into the web service. So nowadays, the modern web service is made of multiple technologies like Node.js, JavaScript, and it runs on a Linux server, and this web application talks to a MySQL database. So we have multiple technologies in a web application, right? So what happens in an injection attack is, so think about this. When you're logging in, you're passing in the username and password field. And we know that the web application is processing this information, right? Now, let's say the backend is flawed. So it's not intentionally flawed, but it was overlooked in terms of security. that what they do is it passes the username without sanitizing to the database and asking, hey, is this username valid? In that case, what if a malicious user crafts a special SQL statement and that goes unchecked to the database? So that means it's bypassing all the security restriction in terms of, and also the business restrictions that we have, and it's going straight into the database, and that SQL statement is getting executed. So that is one of the security vulnerabilities. And this is exactly what we'll be looking during our hands-on tool. So I'll fast forward this, saying you can look at the other 7 OWASP top 10 vulnerabilities to expand your knowledge. So we'll fast forward and go to how do we test for SQL injection in the GoodBanks API that was created by Ronak during the design phase, right? Yeah. So a note here. So this was the API that Ronak had created, and yeah, so this was the API that Ronak had created, and he updated it, right? Now, what we could do is we could generate a collection and start from there. But what we have done for ease of use is we have already created a collection called the GoodBank APIs because it has all the pre-scripts and test scripts in place, which will keep the flow consistent and coherent. So I hope the link is shared.
Yeah, I'll be posting the link in the chat now. If you want to follow along, so instead of like generating the collection, we make it easier for you by providing that collection that's ready to go for that version. So go to the link I just posted in the chat, and then Manoj is just now going to show you how to fork it so you can bring it to your own workspace and start working on it.
Yep. So what we shall be doing is we shall fork this workspace, click on the 3 dots beside the name of the collection in the collections tab, and click on create a fork. And fork label, let's call it something, say space camp API sec. And let me fork it to my workspace. Okay, there's a lot of my workspace in this team. This is specifically my workspace. I'm the only one in that. And fork collection. So as soon as I click on fork collection, I get an acknowledgement that fork has been created, and the web application automatically redirects me to my workspace with that forked collection. There we go. We have all the APIs. Now, what I was asked as a security tester is to test these 2 APIs for injection specifically. So let's have a look at what these API do. Yeah, I think Ronak had touched upon this during the API schema development itself. We need to get the user ID summary, and let's send and see. Whoa, that's nice. Ronak had done a good job. He made sure the security is in place. So I'm getting unauthorized error. So first, let us log in. Right under the bank user folder of GoodBank APIs. So it got zoomed in too much.
It's a nice zoom.
Oh, so user login. Yeah, here is the API to log in and create a session with the bank server. It's already pre-filled with existing username password, so you don't have to take the fuss of creating a user. Let's create a session. Ta-da! So it created the session and it got the session token. So what I meant by coherent was in the test script, we are automatically setting this session token in the collection variable. So you don't have to take the fuss of copying the session token and putting that in the header values here, right? So now let's run this API and see how it works. Oh, actually. Did it actually? That is strange. Anyways, for this purpose, let me use this API.
Sorry, I didn't see. What did you try to do?
Oh, I was trying to change the authorization here, but I think the bank account already has session token and which is already filled. Possibly it's not detecting it, I suppose. Oh,
Is user ID there?
yes,
I think it might be because we're replacing, if you look in the account summary pre-request script, I think you're replacing the user ID with something. So you might want to comment that out for now.
Oh, that's right. That's right.
Yeah, like line 7, it sets the user ID to.
That's right. Okay, let me comment this off for the moment. So what I did was I selected everything and control and question mark or the slash icon to comment all of the code in the pre-request script. So let me save it and run it and let's see. Oh no, not again. This happens during the webinar.
Let's send the login one again, just in case. So that resets the user ID and then send the account summary. You can hover on user ID as well to see what's happening there.
Yes, let me try manually adding the X API key and get that from here.
It worked for people on the chat, so
I hope this is fine. No, it's not. Okay, maybe let me try creating a different user. There we go. Yeah, for some reason, you're not getting a successful login session. So let me create a username and hopefully no one has taken this username. Unique username. And okay, let me copy this password to my clipboard. Okay.
I think you're not allowed underscore in the username.
Right. Okay, username and password. Let me copy this.
Apparently commenting things out worked for most of the people from what I can see on the chat. So we might, okay, so we have a user ID.
Cool. Now unique username and put in the password. And hopefully now that I got a different session token, I hope this should, awesome. There
cool. Whatever happened there, but it works. And it looks like you all have the same thing on your end. So we should be good to keep going.
Sure. Yeah. So once you get a 200 response, you're good to go. So this was, so again, recalling what we did, we just created a different user and logged in, which was supposed to be skipped, but we have to go through this drill and just looked at account summary with a logged in session, right? Now let's get back to action. There we go. So account summary, okay, it gives me balance in last transactions and account transaction. It gives me the list of transactions that is there. Awesome. So let's get started with SQL injection testing. So now specifically for this API endpoint, account transaction, let's test out this filter input field, right? As I mentioned, injection is about tampering the filter, the input fields and making the web server execute something malicious, right? So here, let's first try to break the endpoint. So what I'm going to do is, I assume this is going to terminate an SQL statement abruptly. And let's see if it actually does. Oh, it actually does. So I can report back to the developer and say, hey, the filter field in the account transaction endpoint is actually vulnerable to SQL injection. Now, yeah, we're not going to exploit it, but if we are good hackers, we just report errors. Yeah. Now let's test out injection on the limit field. possibly it's the same developer who has developed it, and terminate the SQL query just like that. Oh, this doesn't seem like an SQL error. It seems like invalid literal for int with base 10. Whoever has seen this error before, what I did was I searched it in my favorite search engine, and it seems like it's a Python value error. So here's actually an information leakage, right? We come to know that the backend is running Python web application. So here it is possible that we can do code injection. I mean Python code injection, right? So we report 2 errors to the developer saying, hey, this API endpoint is actually vulnerable to injection at filter and limit. At filter, it's vulnerable to SQL injection, and at limit, it is vulnerable to code injection. Awesome. Now that we've reported, let's go to account summary and see if we can try and break this endpoint. Right. So here the input is user ID. Right. So let's try to break this user ID. Replace this with a single quotes and send this request. Whoa, that's nice. It says bad pattern. We didn't get any error unlike the first case. Maybe try out double quotes, terminate it abruptly like this. Oh, still the same error with the closing brackets. I mean, I could do this all day long, but I think I want to automate this process, right? So here is where the pre-request script and test scripts will help us. So let me put this back into the original request. And in the pre-request script, we had commented this before. Let's uncomment this before. So let me quickly go through what does the pre-request script do. So first, it loads the list of payloads from the collection variables, right? Yeah, I'm curious, what does collection variable contain? It says variable, and yeah. So actually, the collection variable contains, the collection variable payloads contains a list of payloads that I want to try and inject into the user ID field, right? They're formatted in JavaScript. Now, back to this. Yeah. So it loads all the payloads, and it uses a counter variable, which is again a collection variable. It starts with 0 if it's not defined. And okay, this is used as reference to what payload the current iteration is in, right? And it updates the counter, it updates the user ID so that I can inject it. So all these are happening before the request, right? This code is getting executed before the request. So user ID is set with that particular payload. And we are setting the next request again to account summary. It is because we have more payloads to look at, right? Otherwise, we are setting the next request to account transaction, which is this, and resetting back the counter. Yeah, so all these code is getting executed before the request is actually being sent. And now what are we testing for? We are testing if the status code is not 200 and status code is not 500. So these are the sanity checks. Right now, we're getting 403, right? So we don't want to get 500. That is the sanity check. And we don't want to get 200. 200 as in it actually executed a proper SQL because we know that all these payload that we're passing in is invalid and we don't want to get a 200 response. So these two are the tests that we want to perform after the request is being passed. So now that we have everything set up, what we're going to do is we are going to run this collection. So what I mean by run this collection is when you hover over the good banks collection, right? And click on the 3 dots here, and you see a third option which says run collection. Click on run collection. And for this purpose, for this testing, we are testing only account summary, right? So let me uncheck other requests. We're going through one iteration, delay, no data file, run the GoodBanks API. Wow, that's interesting. it actually failed the test. I think again it's because let me try and send this. Okay, that was good. And let me reset back the counter and try and run the collection again. I see. I think it's possibly because of this, right? No. Okay, let me try and run the collection again. Just this request. Yeah, for debugging purpose, let me save the responses. Awesome. It did run, but yes, it did run for one of the payloads, but it did not run for the other ones. Let me clear off all these.
Did you save the changes?
Yep, I think I did. So here's the account summary.
Yeah, it wasn't saved, so you can it's still commented, so it ran on the unsaved version.
Right.
Which is one of the things you should always pay attention to in Postman. Always save. Like you should always press like Command S or Control S. So that's the #1 case of error usually.
That's right. Awesome. Yeah. So again, click on the 3 dots, run collection, and hopefully this time you've taken care of all the nitty-gritties. And awesome. So
Nice.
it's going through each of the payload and it's executing our tests. Right. Amazing. Now this is good, right? We have all the tests passed. So what we can assume is that account summary, to a great extent, is not vulnerable to injection attacks. And that is what we report to developers and say, hey, we're good to go for production on the account summary endpoint, but hey, you need to take care of the 2 injection attacks possible at the account transactions endpoint. But now, do you want to do this every time a new release is made? Or what if the developer makes changes and he wants to see if he did it right or not? So we want to do some kind of regression testing, right? We want to continuously test for injection at this endpoint. So how do we do that with Postman? We use monitors. Ta-da. So, so what this monitor do is actually what we did right now. We ran a collection on demand, right? So using monitors, we can run this periodically. So here is where, let me uncheck this off. So we can run this periodically. Like let's say I want to run this every day at 10 p.m. and let's call this regression test. Yeah, you can give some name. Misspelled it, regression test, and call this account summary. And we select the good bank APIs collection. Let's leave it to the current tag, no environment set. Leave all these to defaults, and optionally you can send it to email if there are any failures.
Yeah, ideally, in a real world use case, you would want an email like to be warned about it. I think Manoj already gets enough emails in his mailbox, so he's just unticking it now. But yeah, you would probably tick that.
That's right. So let's create a monitor. And yep, there we go. Now that we have created a monitor. Yep. So this runs at 10 p.m. IST, my time, every day. But let's say a release just happened and your application security manager is like, hey, we want to do testing on the API endpoint that was just put for security testing. So what we can do is we can run this monitor on demand also. You don't have to go through all the fuss again, clicking on collection variables and selecting all of them. I mean, deselecting and selecting only the specific ones. Just go to the monitor. You can either use this button or this button here. This is only for the first time. So let's click on run. And there we go. It's running the test on the bottom. Run is in progress. Awesome. It seems like the deployment is again, as safe as how it was before. Yes.
Cool.
So now we have looked at how we can automate security testing and regression testing in small scale. Now I'll be giving to Ronak, where he'll be explaining it how we're doing it in large scale in Postman. Over to you, Ronak.
So right now, as you can see, I'm here in the Postman app. What you can do is, if you want to follow along, just search for the Postman Security workspace, and the top one you should find this one. Click on that. So this is this workspace officially published by Postman Security. This workspace has templates or collections which we internally use. So Postman, as as Manoj demoed, right, has really good use cases around automation on top of the APIs. So what we do is we created we in Postman we do a lot of dog fooding, right? So we check for common API vulnerabilities in the APIs using Postman collection itself, like how Manoj showed. So there's this collection that has all the security tests that, for example, cause misconfiguration, missing security headers, SQL injections, etc. So all what you can do is you can check out this collection. There's a nice documentation around top of that. So using that, you can just follow along, just like how Manoj showed you here, and use this collection to test your APIs for all this configuration. Similarly, there are other DevSecOps collections as well. For example, this one is about domain expiry monitor. So if you or your company is using AWS for their hosting their domains, then you can follow along with this collection and create a monitor which will tell you, which will periodically check all your domains expiry date. So so that one day you don't find out that, hey, the domain I own is now expired. And yeah, uh, there's one good example that we actively use in Postman is emails exposed in data breach. So I'm not sure if you guys have heard about this, but there's this nice website called Have I Been Pawned? So in this website, if you enter your email address or phone number, it will give you it will tell you whether your account has been involved breached in a data breach or not. So you can, for example, I can write ronak@gmail.com and it will show me if my account is breached or not. This is not my real account, so don't worry about
I was
it.
going to say, probably know
Yeah.
what you want to show.
Yeah. Yeah. So, for example, this account, whoever it owned, their account was leaked in several breaches, as you can see here. Big Basket, if people are in, this is the e-commerce website in India. Adobe, we are all familiar with it. So, what this collection does is, within your organization, if you are using Rippling or if any other employee management tool, then we are here currently showing it as a Rippling. So if you're using Rippling, it will fetch all the employees, it will get their personal and work email address, and if it will query this API and if their account was breached and their password was leaked, then they'll notify them via Slack. So it's a nice handy collection to have. There is a lot of more as well. So do check it out. We regularly add more collection to it as we get more time to work on this. So yeah, would really love your thoughts. If you think there is anything is not working there, or if you have any thoughts on this, do share on the community channels as well. We'd love to hear from you. And yeah, that's me. That's
Cool.
about it.
I will
Over to you, Alan.
take over the screen sharing again. And yeah, hopefully are you seeing the slides? Yeah, cool. So remember me, I talked to you 40 minutes ago about what you would learn. And here we'll just go through what you should have learned. And ideally, I think we've seen all of that. Talking about identifying the most common API vulnerabilities and like the best practices for security, how you can identify these from the API design phase all the way to checking them on a like on needed basis to like actually automating these checks. So we've kind of covered all of this. Before we leave, there's a few things, including additional resources. So for example, Ronak mentioned the Postman Security workspace. It's there. You can take a screenshot of that page. The slides will be shared by email anyway later, so you'll have access to it. If you want a more detailed view of like everything OWASP, Ronak and Manoj were on a live stream earlier this year, and so it's a longer format, but they went through all this. So you might be interested in catching up on that video. And then if you have any questions after this webinar is over, feel free to go on the community forum, community.postman.com, log in with your Postman account. I think it's automatic. And then you can ask your question there. We're all like monitoring that anyway, so we'll be able to answer your questions. So quickly, because we have about like a few minutes left, few things to look forward to in the Postman roadmap that are related to security or governance in general. There would be a super admin role, which means you'll be the main person in your account, and you'll be able to handle everything, and you won't need to like go through hoops to get permissions on different things. So there will be someone in your Postman account who would be able to get this super admin role. Secret management, being able to define your secrets somewhere and reuse them in different places of the app, and uptime monitors. So if you want to check that one of your API is up, you can just have this uptime monitor to just check constantly that your API is up and running. There's more. If you're interested in learning more, there's this link here, which is a link to our public roadmap. We're in charge of it. We update it like as soon as we know things that are coming out. So yeah, I recommend checking out. Couple of last things. The Q&A. Luckily enough, Ronak and Manoj were answering the questions as we were going during the thing. So we actually don't have any questions for now, which is good because we're actually running out of time as well. But if you're interested in the questions that were asked, we'll be forwarding them by email as well. I see someone asking about the recording. The recording will be shared by email to anyone that attended or didn't attend. And it's also available on the Space Camp website. So if you look for Postman Space Camp on Google, you'll find our page. All the recording from previous sessions are there. And that's it. So before, at the start, I mentioned a quick survey. Please tell us what you've enjoyed about that session or didn't enjoy. Ideally, someone can post that one on the chat quickly. If not, this one is also being shared by email. Please do let us know. Helps us improve the sessions over time. I see Sandy asking us to share the URL. Let me take a sec and paste it here. Oh, you should have it now. Get that URL, reply to the survey, and we'll ideally take that into account. With that said, thank you, Ronak. Thank you, Manoj. Good stuff. Some live debugging, some tons of security. Hopefully, you all enjoyed it. We have just announced 3 new sessions for 2022 of Postman Space Camp. Do check them out on the website. And in the meantime, see you all next time. Thank you, and bye-bye.